Hello, welcome to today's session, Data Analysis. Data analysis is the process of examining data sets in order to draw conclusions about the information they contain, increasing with the aid of specialized systems and software. Data analysis technologies and techniques are widely used in commercial industries to enable organizations to make more informed business decisions and by scientists and researchers to verify or disprove scientific models, theories, and hypotheses. Data analytics is a broad term that encompasses many diverse types of data analysis. Especially any type of information can be subjected to data analysis techniques to get insight that can be used to improve things. For example, manufacturing companies often record the runtime, downtime, and work queue for various machines and then analyze the data to better plan the workloads so that the machines operate closer to peak capacity. As a term, data analysis predominantly refers to an assortment of applications from basic business intelligence (BI) reporting and online analytical processing (OLAP) to various forms of advanced analysis. In that sense, it's similar in nature to business analysis, another umbrella term for approaches to analyzing data, with the difference that the latter is oriented to business uses while data analysis has a broader focus. Types of data analytics. Data analytics is broken down into four basic types: descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics. Descriptive analytics. Descriptive analytics describes what has happened over a given period of time. As the name implies, descriptive analysis or statistics can summarize raw data and convert it into a form that can be easily understood by humans. They can describe in detail about an event that has occurred in the past. This type of analytics is helpful in deriving any pattern, if any, from past events or drawing interpretations from them so that better strategies for the future can be framed. Examples: have the number of views gone up? Are sales stronger this month than last? Diagnostic analytics. The obvious successor to descriptive analytics is diagnostic analytics. Diagnostic analytical tools aid an analyst to dig deeper into an issue at hand so that they can arrive at a source of a problem. Diagnostic analytics focuses more on why something happened. This involves more diverse data inputs and a bit of hypothesizing. Examples: did the weather affect beer sales? Did that latest marketing campaign impact sales? Predictive analytics. Predictive analytics moves to what is likely going to happen in the near term. Any business that is pursuing success should have foresight. Predictive analytics helps businesses to forecast trends based on the current events. Whether it's predicting the probability of an event happening in future or estimating the accurate time it will happen can all be determined with the help of predictive analytical models. Examples: what happened to sales last time we had a hot summer? How many weather models predict a hot summer this year? Prescriptive analytics. This type of analytics explains the step-by-step process in a situation. For instance, a prescriptive analysis is what comes into play when your Uber driver gets the easier route from Gmaps. The best route was chosen by considering the distance of every available route from your pickup route to the destination and the traffic constraints on each road. Prescriptive analytics moves into the territory of suggesting a course of action. Examples: if the likelihood of a hot summer as measured as an average of these 5 weather models is above 58%, then we should add an evening shift to the brewery and rent an additional tank to increase output. Complexity of different types of data analytics. Advantages and disadvantages of data analytics. Following are the advantages of data analytics. It detects and corrects the errors from data sets with the help of data cleansing. This helps in improving quality of data and consecutively benefits both customers and institutions such as banks, insurance and finance companies. It removes duplicate information from data sets and hence saves large amount of memory space. This decreases cost to the company. It helps in displaying relevant advertisements on the online shopping websites based on historic data and purchase behavior of the users. Machine learning algorithms are applied for the same. This helps in increasing revenue and productivity of the companies. It reduces banking risks by identifying probable fraudulent customers based on historic data analysis. This helps institutes in deciding whether to issue loan or credit cards to the applicants or not. It is used by security agencies for surveillance and monitoring purpose based on information collected by huge number of sensors. This helps in preventing any wrongdoings and or calamities. Now, following are the disadvantages of data analytics. This may breach privacy of the customers as their information such as purchases, online transactions, subscriptions are visible to their parent companies. The companies may exchange these useful customer databases for mutual benefits. The cost of data analytics tools vary based on applications and features supported. Moreover, some of the data analytics tools are complex to use and require training. This increases cost to the company willing to adopt data analysis tools or software. The information obtained using data analysis can also be misused against the group of people of certain country or community or caste. It is very difficult to select the right data analysis tools. This is due to the fact that it requires knowledge of the tools and their accuracy in analyzing the relevant data as per applications. This increases time and cost to the company. Inside the data analysis process. Data analysis applications involve more than just analyzing data. Particularly, on advanced analysis projects, much of the required work takes place upfront in collecting, integrating and preparing data and then developing, testing and revising analytical models to ensure that they produce accurate results. In addition to data scientists and other data analysts, analysis teams often include data engineers whose job is to help get data sets ready for analysis. The analysis process starts with data collection, in which data scientists identify the information they need for a particular analysis application and then work on their own or with data engineers and IT staffs to assemble it for use. Data from different source systems may need to be combined via data integration routines, transformed into a common format and loaded into an analysis system such as Hadoop cluster, NoSQL database or data warehouse. In other cases, the collection process may consist of pulling a relevant subset out of a stream of raw data that flows into, say, Hadoop and moving it to a separate partition in the system so it can be analyzed without affecting the overall data set. Once the data that's needed is in place, the next step is to find and fix data quality problems that could affect the accuracy of analysis applications. That includes running data profiling and data cleansing jobs to make sure that the information in a data set is consistent and that errors and duplicate entries are eliminated. Additional data preparation work is then done to manipulate and organize the data for the planned analysis use, and data governance policies are applied to ensure that the data hews to corporate standards and is being used properly. At that point, the data analysis work begins in earnest. A data scientist builds an analytical model using predictive modeling tools or other analysis software and programming languages such as Python, Scala, R and SQL. The model is initially run against a partial data set to test its accuracy. Typically, it's then revised and tested again, a process known as training the model that continues until it functions as intended. Finally, the model is run in production mode against the full data set, something that can be done once to address a specific information need or on an ongoing basis as the data is updated. In some cases, analysis applications can be set to automatically trigger business actions. For example, stock trades by a financial services firm. Otherwise, the last step in the data analysis process is communicating the results generated by analytical models to business executives and other end users to aid in their decision making. That usually is done with the help of data visualization techniques, which analysis teams use to create charts and other infographics designed to make their findings easier to understand. Tools used for data analysis. The growing demand and importance of data analysis in the market have generated many openings worldwide. It becomes slightly tough to shortlist the top data analysis tools as the open source tools are more popular, user-friendly and performance-oriented than the paid version. There are many open source tools which doesn't require much or any coding and manages to deliver better results than paid versions. Some of them are KNIME. KNIME Analysis Platform is the leading open solution for data-driven innovation, helping you discover the potential hidden in your data, mine for fresh insights, or predict new futures. With more than 1,000 modules, hundreds of ready-to-run examples, a comprehensive range of integrated tools and the widest choice of advanced algorithms available, KNIME Analysis Platform is the perfect toolbox for any data scientist. OpenRefine. OpenRefine, formerly Google Refine, is a powerful tool for working with messy data, cleaning it, transforming it from one format into another, and extending it with web services and external data. OpenRefine can help you explore large data sets with ease. R programming. R is the leading analysis tool in the industry and widely used for statistics and data modeling. It can easily manipulate your data and present in different ways. It is primarily written in C and Fortran, and a lot of its modules are written in R itself. It's a free software programming language and software environment for statistical computing and graphics. The R language is widely used among data miners for developing statistical software and data analysis. Ease of use and extensibility has raised R's popularity substantially in recent years. Besides data mining, it provides statistical and graphical techniques including linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, and others. Orange. Orange is open source data visualization and data analysis for novice and expert and provides interactive workflows with a large toolbox to create interactive workflows to analyze and visualize data. Orange is packed with different visualizations from scatter plots, bar charts, trees to dendrograms, networks, and heat maps. RapidMiner. Much like KNIME, RapidMiner operates through visual programming and is capable of manipulating, analyzing, and modeling data. RapidMiner makes data science teams more productive through an open source platform for data prep, machine learning, and model deployment. Its unified data science platform accelerates the building of complete analytical workflows from data prep to machine learning to model validation to deployment in a single environment, dramatically improving efficiency and shortening the time to value for data science projects. Pentaho. Pentaho addresses the barriers that blocks your organization's ability to get value from all your data. The platform simplifies preparing and blending any data and includes a spectrum of tools to easily analyze, visualize, explore, report, and predict. Open, embeddable, and extensible Pentaho is architected to ensure that each member of your team, from developers to business users, can easily translate data into value. Talend. Talend is the leading open source integration software provider to data-driven enterprises. Our customers connect anywhere at any speed, from ground to cloud and batch to streaming data or application integration. Talend connects at big data scale, 5x faster and at 1/5 the cost. Weka. Weka, an open source software, is a collection of machine learning algorithms for data mining tasks. The algorithms can either be applied directly to a data set or called from your own Java code. It is also well suited for developing new machine learning schemes since it was fully implemented in the Java programming language, plus supporting several standard data mining tasks. For someone who hasn't coded for a while, Weka with its GUI provides easiest transition into the world of data science. Being written in Java, those with Java experience can call the library into their code as well. NodeXL. NodeXL is a data visualization and analysis software of relationships and networks. NodeXL provides exact calculations. It is a free, not the pro one, an open source network analysis and visualization software. It is one of the best statistical tools for data analysis, which includes advanced network metrics, access to social media network data importers, and automation. Gephi. Gephi is also an open source network analysis and visualization software package written in Java on the NetBeans platform. Think of the giant friendship maps you see that represent LinkedIn or Facebook connections. Gephi takes that step further by providing exact calculations. Applications of data analysis. Now, below are the various areas where data analysis applications have been employed. Policing or security. Several cities all over the world have employed predictive analysis in predicting areas that would likely witness a surge in crime with the use of geographical data and historical data. Although it is not possible to make arrests for every crime committed, but the availability of data has made it possible to have police officers within such areas at a certain time of the day, which has led to drop in crime rate. Fraud and risk detection. This has been known as one of the initial applications of data science, which was extracted from the discipline of finance. So many organizations had very bad experiences with debt and were so fed up with it. Since they already had data that was collected during the time their customers applied for loans, they applied data science, which eventually rescued them from the losses they had incurred. This led to banks learning to divide and conquer data from their customers' profiles, recent expenditure, and other significant information that were made available to them. This made it easy for them to analyze and infer if there was any probability of customers defaulting. Manage risk. In the insurance industry, risk management is the major focus. What most people aren't aware of is that when injuring a person, the risk involved is not obtained based on mere information, but data that has been analyzed statistically before a decision is made. Data analysis gives insurance companies information on claims data, actuarial data, and risk data covering all important decisions that the company needs to take. Evaluation is done by an underwriter before an individual insured, then the appropriate insurance is set. These days, analytical software is used for detecting the various forms of fraudulent claims. Risky claims are detected by red flag indicators which can be examined. It is very essential to bring such claims to the attention of administrators due to the manner at which automation is improving claims processing efficiency. Delivery logistics. Well, data science and analysis have no limited applications. There are several logistic companies working all over the world such as UPS, DHL, FedEx, etc. that make use of data for improving their efficiency in operations. From data analysis applications, these companies have found the most suitable routes for shipping, the best delivery time, most suitable means of transport to select so as to gain cost efficiency, and many others. Also, data generated by these companies through the use of GPS gives them enough opportunities to take advantage of data analysis and data science. Web provision. There is this general belief that smart cities have fast internet speed provided either by their government or companies present there, therefore declaring them smart. Well, just because people can access Facebook or YouTube at the speed of lightning doesn't necessarily make a city smart. Although there may be the presence of fast internet, but this is just one thing. It needs to be present in the appropriate place and accessed by the right people as well. The key component of this is being able to shift bandwidth at the right time and location. This can only be achieved by the use of data. The main assumption is that commercial and financial areas should have the highest bandwidth during weekdays, while residential areas should get such on weekends. The real truth is that this situation is more complex than it looks, and this can only be solved by data analysis application. For example, if a particular community wants to get the attention of web development companies and high-tech industries and make them establish there, a higher bandwidth would be required. Only data analysis could get this done effectively. Proper spending. Another issue with smart cities is the large amount of money spent on little work. Small changes or landmark remodeling, which one would dismiss as unnecessary projects, consume so much money. Data analysis applications would target where taxpayers' money would have a major impact on and the kind of work that they would be adequate for it. The targeting of where this money should be spent would lead to the entire city's infrastructure getting a facelift with a reduction of excess money spent. Customer interactions. This is another one of the applications of data analysis in insurance. Insurers can determine a lot about their services by conducting regular customer surveys, mainly after interacting with claim handlers. They could use this to know which of their services are good and the ones that would need more improvement. Various demographics may desire diverse methods of communication like in-person interactions, websites, phone, or just email. Taking the analysis of customer demographics with feedback can help insurers improve on customer experience depending on customer behavior and proven insights. A study recently carried out showed that a lack of investment in technology was the cause customer dissatisfaction of the present generation of insurance customers because they prefer using mobile and online channels, social media and other recent mediums to interact with their agents. However, the older generation still prefers the use of the telephone. To improve the overall experience of customers, it is best for insurance companies to provide a wide range of communication methods for their customers. City planning. One big mistake being made in many places is that analysis is not considered when pursuing city planning. As a matter of fact, web traffic and marketing are still being used instead of the creation of spaces and buildings. This really causes a lot of issues to power over data due to influence on things like building, zoning and amenity creation. Models that are built will maximize the accessibility of specific areas or services while the risk of overloading significant elements of the infrastructure in the city is minimized. This implies that it creates efficiency. We usually see buildings that are built on spots that look suitable but actually have a negative effect on other places. This is because such issues were not considered during the period of planning. Data analysis applications as well as modeling would make it easy to mark the outcome of erecting a structure on any spot. Healthcare. One challenge most hospitals face is coping with cost pressure in treating as many patients as possible considering the quality of healthcare's improvement. Machine and instrument data use has risen drastically so as to optimize and track treatment, patient flow as well as the use of equipment in hospitals. There is an estimation that a 1% efficiency gain will be achieved and would result to over $63 billion in worldwide healthcare services. Travel. Data analysis applications help in the optimization of travelers' buying experience via social media and mobile or weblog data analysis. This is because customers' preferences and desires can be obtained from this, therefore making companies sell products from the correlation of the current sales to recent browse to buy conversation through customized offers and packages. Data analysis applications can also deliver personalized travel recommendations depending on the outcome from social media data. Energy management. We are in an era where firms apply data analysis to energy management and cover areas like energy optimization, smart grid management, distribution of energy and building automation for utility companies. Data analysis application here focuses mainly on monitoring and controlling of dispatch crew, network devices, and make sure service outages are properly managed. Utilities get the ability to integrate as much as millions of data points within the performance of the network, which allows the engineers make use of the analysis in monitoring the network. Internet or web search. When one mentions the word search, the first thing that comes to the mind is Google. In fact, Google to some point can be used in place of search on the internet by saying Google it. Well, apart from Google, there are several other search engines such as Bing, Yahoo, DuckDuckGo, AOL, Ask, etc. Each of these search engines is a result of data science applications because they use algorithms to deliver the best results for any search query directed at them in just a split second. In respect to this, Google is known to process over 20 petabytes of data daily. Of course, without analysis and data science, this feat wouldn't have been possible. Digital advertisement. Apart from web search, there is another area where data analysis and data science serves a very important purpose: digital advertisements. From the banners displayed on several websites to the digital billboards seen in the big cities, all are controlled by data algorithms. This shows why digital adverts get more CTR than the conventional way of advertisements. Targets depend solely on the past behavior of users. The importance of data analysis applications cannot be overemphasized because it is used in almost all areas of life today. We can see that having data is very important before making certain decisions so as to avoid necessary issues. Also, handling valuable data efficiency could lead to several problems like different departments in an organization not understanding how to make use of it, which would lead to data not used to its full potential or serving any purpose. However, data has become more available and accessible to more people, therefore no longer at the disposal of data scientists and analysts. Almost everybody within an organization can make use of data for the increase of productivity and make very important decisions. Of course, proper use of data would have a positive impact on business and even the society in general. Analysis of education. The rapid advancement of big data analysis makes it necessary for any organization to coincide it with their management and measurement processes. While considering the education sector, it is now becoming essential to analyze data for the development of both learning and academic activities. So, the analysis in education sector can be divided into two broader categories: learning analysis and academic analysis. Learning analysis is the measurement and analysis of collections of data about learners and their contexts for making learning more and more effective. Academic analysis is concerned with the improvement of resources, processes and workflows of the academic institution through the use of learner, academic and institutional data. The following are the applications of data analysis in education. To help individual learners. LA can help individual learners to identify their weakness and achievements and to relate their behavioral patterns with others. Learners' motivation, success and confidence can be enhanced by providing them timely information about their performance. Suggestions on individuals' activities can also be provided to identify significant knowledge gaps. Rapid achievements of learners are possible through providing them access to the tools to evaluate their progress and to identify the activities that produces best results. To help mentors. Analysis can make it easy for teachers to identify the students who require extra support and attention. Mentors can utilize their time and effort from the analytical information on students' weakness and ability and can find proper interventions for individual students. They can also identify the proper teaching practices that have the best impact on the students. To help developing curriculum and learning processes. Through analysis, it is convenient to find out the flaws of current courses and contents and to improve the curriculum offerings. Through the utilization of analyzed data generated during real-time learning activities, better curriculum development and advanced quality learning can be achieved. Individual learner can receive resources and training according to their knowledge state through the personalization and adaptation of developed learning process and contents. To help administrators. Administrators can take decisions on different efficiency and effectiveness measures based on the analytical information of real-time data. So it becomes easy for them to identify retention, progress and completion factors of the organization. It is also possible to reduce attrition through the early detection of at-risk students and generating alerts for learners and educators. Thank you for watching today's program. Thank you.